Hello everyone, Mr. Minnick is my name, Matt is my name, and on today, this particular lesson is going to introduce the unit circle. My Algebra 2 class, I've just given the ones who are not taking the test, I've just given them a copy of this, and that, what you see there is a unit circle. And over the next 2 weeks, we're going to know that unit circle inside and out and forward and back and up and down and all around. One thing about the unit circle is it's a circle. And circles are pretty cool. They have some things about them that you probably already know. Some attributes, and that's what we're going to be talking about in this introductory lesson. So the first thing we'll do is we'll define the unit circle. The unit circle is, by definition, a circle. Surprise, surprise. That's a nice, sensible definition. The unit circle is a circle. When we talk about circles, it doesn't make sense to use the word whose, but we're going to use the word whose. Whose. So there's a couple of qualities about this that you need to know, and they mention them in the definition. The unit circle is a circle whose. If I were to take a circle and go from that point right there to this point right here, there's a name given to that particular line segment. Anybody remember what it is? That part of the circle? It's a radius, right? So by definition, the unit circle is a circle whose radius is equal to 1. Whose radius is equal to 1. And whose, this part of it, what's that part of the circle? Really tall people play this in basketball. Center, thank you. And whose center is equal to the order pair 0, comma 0. Okay. So the center is 0, 0, and the radius is 1. So that's what the definition of the unit circle is. Pretty cool. There's a lot of information that goes along with this. I'm going to say a statement. You'll hear me say this many times. It sounds redundant. It sounds like I'm saying the same thing over and over again. It sounds like it's overkill. But here's the statement. A radius is a radius. That sounds really redundant. It sounds like I'm saying the same thing over and 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 over. Again. There's a reason I said it. You'll hopefully see later on. So let's take a little trip down a rabbit trail about circles. On circles, x minus h, the quantity squared, the quantity of x minus h, the quantity squared, plus the quantity y minus k, the quantity squared, is equal to r squared. That's something that I probably should have mentioned to you prior to you taking the ACT. For circles, that's the general form. That's the general form. General form for a circle's equation. For a circle's equation. For a circle equation. In case you're wondering what each part means or what each part stands for, the coordinates h and k collectively make up the center. So the center is at the coordinates h and k. And we said earlier that the radius is a radius is a radius. Of course, then the radius is r. Okay? case of the unit circle then, so for the unit circle, we can go ahead and actually plug some numbers in here and see what happens. X is still going to be x, so we're going to have to plug the x minus our centers in the order. So h is going to be 0, so it's x minus h squared plus the coordinates are for the center are 0, 0, so it's y minus 0, the coordinate squared. And we said the radius of the unit circle is y. So that's going to equal 1 squared. And if I simplify this, that's going to be x squared plus y squared equals 1. So that's the equation if we wanted to try to maybe somehow graph the unit circle. So what I'd like to try to do is I'd like to try to take this and see if we can't graph the unit circle on the TI Inspire. See if we can't do that. But the interesting thing, if we try to graph that on the Inspire, is the Inspire usually wants a y equals something, not a y squared equals, or 1x squared plus y squared. So what I'm going to do is I'm going to take this equation, x squared plus y squared equals 1, and I'm going to try my best to isolate the y. It'll just take a little bit of algebra, it's not that bad, not too bad. So y squared is going to equal 1 minus x squared, and if I take a square root, y is equal to the square root of 1 minus x squared. So if I plug that into the calculator, I should get the graph of a circle centered around the origin with radius 1. So most of you know how long my calculator takes to load, so I probably should have brought that up moments ago. So one thing I didn't do when I graphed that unit circle the first time is I didn't really superimpose it on the coordinate plane. Remember the Cartesian plane, x, y, O stands for the origin. We have our different quadrants. So the unit circle should be a circle. It's very tiny on this because the radius is only 1. So the unit circle, should look like that on this 10 by 10 graphic. So far so good? Alright? So that's what the unit circle ought to look like. And when I graph this on my calculator, maybe, it's still thinking, it's working on it. Don't have that many windows open, so it should load any decade now, maybe before 2020. What you're going to be surprised to see is that that's not what shows up on the graph. That's not what shows up on the graph. While I'm waiting for that calculator to load, if you think back to a vertical line test, I don't know if you remember how a vertical line test works, but if a vertical line goes through more than one point at any given time, then we don't have a function, right? We don't have a function here. That's not a function. What you're going to be surprised to see is that y equals the square root of 1 minus x squared. When you graph it, you're only going to get the top portion of this circle. And I'll show you that right now. If this decides to cooperate now, here we go. The square root of 1 minus x squared. There, you just get the top half. Some of you are probably wise to the fact that when you get the bottom half, if we plug in another function, anybody know what the other function would be? To get this bottom half, to get this portion of it, anybody know what we'd have to also graph? Well, the graph y equals the opposite of the square root of 1 minus x squared. Think that'll get it done? Let's find out. So tab, the second function, the opposite of the square root of 1 minus x squared. Well, let's try that again. Don't know what happened there. Maybe that's what happens when you don't watch the screen. Syntax error. Oh, no, believe me, I know. I know there's a syntax error. Okay, so let's try that again. It's the opposite of the square root of 1 minus x squared. And there it is. There's the bottom half of the circle. Okay. So keep in mind that this unit circle really is, in fact, when we graph it, it's on a Cartesian plane. A lot of times we don't look at the Cartesian plane, but when we talk about the unit circle, technically the unit circle is in the Cartesian plane. So what I mean by that is anything that applies to the Cartesian plane, like the names of the quadrants, is also imperative to our study of the unit circle. So if we think this is quadrant 1, this is quadrant 2, we got the origin, we got quadrant 3, and we got quadrant 4. Remember, we use Roman numerals when we talk about those. And there's something else that goes along with these quadrants, and that's our S, I, G, and S, the signs of the ordered pairs in those quadrants. In quadrant 1, the ordered pairs are positive and positive. In quadrant 2, the ordered pairs are negative on the x and positive on the y. In quadrant 3, x and y's are all negative. And in quadrant 4, our x's are positive and the y's are negative. So all those things that apply to the Cartesian plane are going to apply to the unit circle. You're going to need to be highly familiar with it. You're going to have to be mindful of it. All right. So we said circles are defined this way. Just if you ever run across this on an ACT, you take the ACT sometime soon, and they say a circle has its center at -2, 5 with radius equal to the square root of 8, not the square root of 8, let's make it the square root of 11. Write an equation, write an equation. So hopefully now you have enough information where you'd be able to do something like that. Take the ACT again in the upcoming weeks or months. So remember the formula is x minus h squared plus y minus k, the quantity squared equals r squared. Center is hk, and here's our radius. Our radius is the square root of 11. So if we wanted to write the equation for this particular circle, we could make some substitutions. X minus 2 squared plus y minus 5 squared equals the square root of 11 squared. All right, so with this equation, then we can go ahead and simplify this. X minus 2 is going to be x plus 2, the quantity squared. The quantity y minus 5 is going to be plus 1 y minus 5, really nothing to clean up there, squared. And this, when we square the square root of 11, that's going to be just 11. So that would be the equation of a circle whose center is at -2, 5 with radius the square root of 11. Okay, so on the flip side of that, they might give you the equation of a circle and ask you what's its center, what's its radius. Hopefully, if you ever run across that on the ACT, now you'll be a little bit more prepared to do that. I know a couple of juniors have taken the ACT. What are the questions about circles on it? Some versions of the ACT have it, some don't. So, okay. All right, one thing that also is a part of the unit circle is near and dear to my heart. You know, my name is Mr. Matthew Minnick, and there's a skill that I believe is not utilized anymore. That is a skill. It's a perishable skill, in fact. You know what happens to old math teachers? They start to lose some of their functions. Memorization. If you don't routinely try to memorize things, your brain is going to be out of practice and you're going to struggle to memorize them. The advent of the cell phone has led us to not know numbers. Do you know your grandma's phone number? Do you know your grandma's address? Do you know your social security number? Do you know Gary Sanderson Jr. third social security number? Anyway, memorization is probably about 7/8 of what we're going to be doing in the next 2 weeks. You're going to have to memorize this. In years past, what students have tried to do is they've taken their hand. Maybe I should have one of our artistically talented people draw this, but they'll take their hand and they'll write stuff about the unit circle on their fingers, on their hands, and the sheet. I hope by now everybody knows how I feel about cheating. I'm pretty sure they do something. But anyway, so help me if I catch you cheating. There will be great penalties. Whatever the assignment is, you'll get a 0 for that, and no chance to make it up. Anyway, you're going to have to memorize this stuff, and that's why I have hundreds of copies of the unit circle. So, the first thing that we're probably going to need to memorize is going to be all the angle measures, in standard position. In standard position, we'll talk about what that means. In standard position, using the measurement known as degrees. Most people are familiar with degrees. If you took geometry last year, which most of you did, some of you might be doubling, you should have an idea what we're talking about with the standard position. If you don't, well then your geometry teacher, I don't want to bash the geometry teacher said they did a great job. But your geometry teacher at some point should have mentioned what it means when you have an angle in standard position. You have one of these things. That is a line. It's a part of the line. It's a line that's got, well, it's not a whole entire line. It's got one endpoint, and it extends in one direction forever. What's that called? It's a 3-letter word. It's a man's name sometimes. It's what the sun emits. Ray, thank you. So this is a ray, and when we talk about standard position, we talk about the first ray that we draw, and when we draw something first, we draw it initially. So this is called the initial ray. And if something's in standard position, what that means is the initial ray faces due east. I don't understand why the high school curriculum doesn't require you to learn geometry. I think everybody should know the difference between north, south, east, and west. It's a shame that people can't get anywhere without using GPS nowadays. I love my wife dearly. She'll say, how do I get to where I'm going? I'll say, oh, you take 82. She's like, don't tell me all that, just give me landmarks. I say, no, you take 82 east to 44 north. It's pretty simple. Well, what do you mean landmark? Well, you know, it's 82 east to 44 north. It's just so simple. Anyway, due east. So if you think about the compass, there's an N that stands for north. So south is under north, and east is over here, and west is over here. So the initial ray has to face due east. There's another ray, it's the last one that you sketch, and sometimes it happens to face in the exact same direction. It's also a ray, and it's called the terminal ray. It's called the terminal ray. It has nothing to do with airports. It has nothing to do with getting fired. It just means it's the last ray that we draw. If both rays are facing the same direction, we'll talk about what that angle measure is, but usually these rays are going to be separated. They can be separated by as much as 359.999999999. Well, maybe not, because I better not say it that way. So if we have a terminal ray facing there, now the question is, okay, what angle are we talking about? Because when we talk about the standard position, not only do we need an initial ray, not only do we need a terminal ray, but we also need a directional indicator, a directional indicator. If you've ever played Super Mario for the original Nintendo system, it's probably the most basic game ever, because Mario only runs one direction. I mean, you can go back a little bit, but usually he's running this way. To the east, to the right? So, when you talk about measuring angles in standard position, there's one way that the directional arrow normally goes. And it's anti or counterclockwise. Okay? Some people call it anti-clockwise. Some people call it anti-clockwise or counterclockwise. It can go the other direction, and if it does, those angles have a negative measure. But if we have an arrow that indicates the direction goes this way, that angle would have a positive measure. And that angle there is probably somewhere between, well, it's definitely somewhere between 0 and 90. It's probably around 40 degrees, give or take. It's probably about 40 degrees. Okay? Positive 40 degrees of that. So, I think somewhere here I have an angle measuring device. One of those angle measuring devices is called, thank you, protractor. I always get it twisted. I always confuse protractors and compasses. Is it compasses or combine? I don't know. Yeah, it's about 40 degrees. About 40 degrees. Okay. So to be clear, if I had an angle like this, if I had an angle like this, that angle is not in standard position. If I want to make that angle in standard position, my initial ray would have to face due east. Now I have an angle in standard position. But now you got to think to yourself, okay, well, which angle is he talking about? If I draw this directional indicator, well, that's a pretty big angle, isn't it? Bigger than 180. So if I measure it that way, that might be close to like 250 degrees, positive 250 degrees. We wouldn't write the plus necessarily. But if I measure that angle going this direction, it's a little bit bigger than 90 degrees, but it has a negative measure to it. It's 20 degrees past 90, so it'd be negative 110. Okay? So what we would say then about a 250 degree angle and a negative 110 degree angle is we would say that they are co-terminal. Those happen to be co-terminal. They terminate in the same place. They're really the same angle. It's just a different way of measuring it. For instance, I live in Newton Falls. So when I come here, I'm 12 miles east of where I live. If you live in Mantua, and you come here, you're 8 miles west of where you live. Happen to be the same place, it's just a different way of measuring. Okay? So it's the same kind of idea there. Just to go ahead and measure that to be sure, let's see how we did it with that. Doesn't have to be exact, but so it'd be like 180 plus another 70, 180 plus 70, yeah, that's about 250. Yeah, about 250. And then the other one is 100, about 110, yeah, 110. Okay. Cool beans. Are there any questions about what it means for an angle being in standard position? Okay. The rest of this lesson today is going to be pretty easy. All we got to do today then is we're going to talk about all 16 angle measures, on the unit circle. So that's one of the two things that we're going to be doing. And then we are going to be looking at coordinates also. We are going to be looking at coordinates at what I like to call the poles. There's a North Pole, there's a South Pole. You're not allowed to fly over the South Pole or whatever. There's no such thing as East Pole or the West Pole, but I like to call them the poles. Maybe I should give them a different name. But anyway, so in the remaining part of this lesson, what we're going to be doing is we're going to be trying our bestest to complete the unit circle by filling in the angle measure here, the angle measure here, and here, and here. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 16 reference points along this unit circle. And we're going to go ahead and figure out what those are. And sometime in the very near future, you're going to be taking a time test or quiz with this material. What's it going to be timed? Well, I said that this is a skill that people don't practice enough. So we're going to be practicing this. You're going to be memorizing this. And if I'm being honest, it should be a chance for people to have their grade for the 45 minutes. Traditionally speaking, C and D students who are good at memorizing end up with a B during the quarter when we do the circle, just because they can memorize it. So anyway, I want to go ahead and make my green initial ray. So we'll make that green. Maybe. So there's my initial ray. I'll get my terminal ray going. So that first angle right there, the one where the initial ray and the terminal ray are coterminal. Anybody know the measure of that in degrees? There's no angle. The angle didn't open up a bit, so what's this measure in degrees? 180. 0, good. So this angle right over here then, that due east is 0 degrees. Alright, we'll take our terminal ray and we'll keep on trucking with it. Let's truck this right on around. When we go up to here, let's go up to the North Pole first. I think it'll be easier to see at the North Pole. When we go to the North Pole, how many degrees have we gone down from 0? 90. Is it positive 90 or is it negative 90? It is positive 90, good. Okay, so that's 90. So over here, due west is going to be what? 180 degrees. When you take the quizzes over this, I'm not going to require you to put a little degree symbol. Okay, I know that this degrees. South Pole, the measure down there, this one, some people forget it. They don't know it. Now, work on that again. 270, good. It's 270 degrees. Now, whenever you have this 0 degree angle, anytime you make it, whether it's with degrees or the other measurement, I do want you to have both the 0 degree angle and if we make one complete revolution like we have, if we make one complete revolution, what is another way to measure that angle? If we have one complete entire revolution. What's another measure for that angle? 360, right? So I do expect to have both 0 and 360 on those time tests and quizzes. I expect to have both of those just for that reason. None of the other ones, but for that one. We doing okay so far? All right. Good. So on this unit circle, then, we're going to be bisecting some stuff, and we're going to be trisecting some stuff, if that's even a word. I don't know if trisect is a word. But if we bisect a 0 and a 90 degree angle dead smack in the middle, what are we going to get right there? Yeah. All right, so it's going to be a 45. So that's going to be a 45 degree angle. Bisecting over here between the 90 and the 180 is 45 more than 90 or 45 less than 180. And when people take the test on this, for whatever reason, people have a hard time adding or subtracting 45 to 90. They forget about carrying the 1 or maybe they carry 1, I don't know. 135. Or it's 135, good. So that's 135 degrees. Moving down to quadrant 3, bisecting the 180 and the 270 is going to be 45 less than 270 or 45 more than 180. 225. That one always reminds me of driving through, what township is that over where West Branch is, with the road, the Hilly Road? Oh, what is that Hilly Road? And lastly, in quadrant 4, halfway between 270 and 360, we're going to be 45 less than 360 or 45 more than 270. This is another one that people mess up. 315, good. 315 degrees. This is pretty straightforward so far, isn't it? I'm not allowed to bet in school, nor do I encourage betting or gambling. It's actually against the school policy. But anyway, I would be willing to guess that just about everybody here tomorrow can take a test on this and fill in all 16 angle measurements without problem. Not saying I'm going to do that, but I would be willing to venture that everybody can. Anyway, so let's go back up to quadrant 1. So I mentioned the word trisect. This part, well, let me get a different colored marker going here. This angle, let me go. This angle here, let's try to get a marker going. This angle formed here, and this angle formed here, and this angle is congruent to this angle is congruent to this angle. Can you see that? Is that 90-degree angle is essentially trisected? So, when I'm over here, then what's the measure of that angle? 1/3 of 90 degrees. It's going to be 30. So over here is going to be 30 degrees. Similarly, here is 30 degrees less than 90. 30 degrees less than 90. So what's that one? 60, good. 60 degrees. So a couple things worth noting. When I go that far, that's 30 degrees. When I go from here to here, that's 15 degrees. And from here to here is also 15. And from here to here is 30. And the whole way around the circle is symmetry. So filling in the rest of this probably isn't that bad then. If we go to the first click past 90, that's going to be 30 more than 90. So what's that one? What is it? 120, good. And then the next click is 15 past that, which we got. And then it's 15 past that, or it's 30 less than 180. So 30 less than 180 or 15 more than 135. That's going to give us what? 150, right? Cool. So then moving into quadrant 3, the first one past 180 is 30 degrees past 180, so it's 20 plus 30. So that's, what is it? 15, 210 degrees, good. And then we'll go 15 to 225, we'll go another 15, or 30 less than 270. It's handy to know that. It's either 30 less than 270 or 15 more than 225, so what is it? 240, good. So that's 240 degrees. Moving on to quadrant 4, when we make this swing here, that's 30 past 270. That's pretty easy. We'll keep it real. 3 times. Keeping it real. Times 3. 300. Did they still say that? That was 8 months ago. I'll say, keep it 100. Alright, so then we got 315, and the last one is great. This is where we lose it. So 3 up. 330 degrees. Okay. So again, memorization. I expect everybody to be able to fill all of those measurements in on the circle on a time quiz. I'm not saying it's going to be tomorrow, but next week sometime. Probably Wednesday next week. So that takes care of all 16 angle measures in degrees. So we really only have one more thing to do today. We're almost done. The last thing we got to do today is talk about the coordinates at the poles. The coordinates at the poles. So I call this the North Pole, the South Pole, the East Pole, and the West Pole. This is what I mean when I say the poles. I know there's no such thing as an East Pole or a West Pole, but that's what I call it. Some people might call them cardinal directions. I don't know why they're called that. They're called cardinal directions sometimes. So what we're looking at here is we're looking at the coordinates. We're looking at the coordinates. When I say coordinates, I mean ordered pairs. I mean ordered pairs. I mean parenthesis x, comma, y in parentheses. So, maybe we should go back to the definition for a second. Well, for a couple of seconds. The definition of a unit circle is that a unit circle is a circle. It's a circle. Whose radius is 1 and whose center has the coordinates 0, 0. And a radius is a radius is a radius. Well, if you take the quizzes on this, I'm not going to ask you to label the center, but it is handy to know that the center has coordinates 0, 0. There at the origin. Right? Handy to know. Also handy to know that the radius of a unit circle, is 1. Also handy to know that the radius is a radius. I'll say that, I'll write that again. A radius is a radius is a radius. So what you're going to need to do is right here, tell me what the coordinates are. And up here, be able to tell me what the coordinates are. And over here, be able to tell me what the coordinates are. And down here, be able to tell me what the coordinates are. What do we got? They all 1. Are they all 1? So 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, like that? Like 0, 1, 0, 1. 0, 1, 0, yeah, that's the idea. So let's see if we can figure these out. Let's start at the east pole over here. Let's go over here. So the center is 0, 0, and we went straight across, right? So what's that going to be over there? What's the coordinates going to be? I got to be honest with you. This is probably the easiest one, but it's also the easiest one to screw up. When I grade these, these are the ones I look at to screw them up. Anybody know the coordinates over there? A radius is a radius. If we go from here to here, we've gone 1 unit, right? The x value, the x coordinate has increased by 1. From what? From 0. So what's the coordinates over there? 0, 1 or 1, 0? One of those. 0, 1 or 1, 0? Our x coordinate increased by 1 because here's 1, 0. There's 1, 0. There'll be 1, 0 over here. There's 1, 0 over here. What happens when we go up to the North Pole? Keep in mind that's in line with the same x value, so the x value is not going to change. So that's 0, 1 there. Let's go to the South Pole. Still in line, same x value, so at the South Pole it's going to be 0, negative 1. And moving over to the west, the coordinates at the west are negative 1, 0. So to be clear, coming up in the near future, what I'm going to expect you all to be able to do in about a minute and a half. And you have plenty of unit circles to practice on, there's plenty of copies of that. Feel free to grab as many as you want. In 1 minute's time, I expect you to be able to go 0, 3, 6, 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, and the coordinates 1, 0, negative 1, oh, that's it, 0, 1, 0, negative 1, and negative 1, 0. I expect you to be able to do that in a minute and a half's time. I don't think that's out of reason, but that's coming in the very near future. Questions? Comments? It's been real, it's been fun. This has been Unit Circle Introduction. We've just begun. Have a great day. See you.